Welcome back to the Organic Chemistry playlist. In this episode, we have a practice problem. So I'm going to ask you here, how can you track the progress of a reaction from this compound, from the para or 4-methyl phenol to, let's say, and this would be 3-methylphenol. Geez Louise. So how would you track this reaction progress through the use of C-NMR, or carbon-13 NMR, I should say? How would you track the reaction progress? Okay, so let's go over the answer here. Hopefully you had a second to think about it. Trying to think what color. I'll go with white. I haven't used a white yet in any of these videos. Anywho, so we need to, for carbon NMR, we know there will be a distinct signal at different carbon environments. And there's a difference here between these two molecules in relative carbon environments. Let's first look at these carbon environments for 4-methylphenol. So let's look at just the carbon environments. We have one here. We have one here. And we also have one here. Notice how there's a plane of symmetry through this molecule. That tells us that these carbons here are equal to these carbons. Because if I took this molecule and I blindfolded you, so here's you over here, and you're all happy, and then I just blindfold you, and I spun this molecule around really fast, and kind of like, when you're at a game and you're playing a yard game and you spin around the baseball a million times and you get all dizzy and you're like, where the hell am I? Imagine I did that with the molecule, and then I unblindfold you and I tell you which carbon was the one that was originally left. You would have about a 50-50 guess on which carbon is actually that carbon, right? Because they're not chiral, and because of that, they're chemically equivalent. Alrighty, so given that these are chemically equivalent carbons, we know that this molecule here will give rise to 1, 2, 3, 4, 5 signals. On our carbon-13 NMR spectra. So hopefully you could see that there. Now let's move on to 3-methylphenol. What are the carbon environments looking like here? Well, notice there is no longer symmetry in this molecule. We can't just, if I had Billy here look at this carbon relative to this carbon, and I spun the molecule around, well, he could pretty easily deduce which carbon is which. And that's because there's no symmetry in the molecule. So respectively, we have a carbon environment here, 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 here. All the carbons are separate from each other, and they're all going to experience a different space on or a different shielding or deshielding effect because of the presence of this oxygen and the extra carbon. It's not a homogeneous symmetrical molecule. It's unsymmetrical, and because of that, no carbon on this molecule is the same. And we'll look at looks like 7 respective signals for this molecule. So we have 7 signals. So when you're tracking the progress of the reaction, if you see 5 signals show up, well, you know that you have your paraphenol. But if you look and you have 7 signals on your carbon-13 NMR spectra, well, then you know you have your meta product. So hopefully that helps, and yeah, stay